Hi students, I am going to do some concrete proofs, and I found this virtual manipulatives online. So I'm going to use this. I tried for like a half hour to video myself moving little chips around on paper, and I just cannot video, talk, and hold the camera all at the same time. It just was not working. So I'm going to give this a shot. All right, this first proof. All right, I'll say this twice. This one is from one of the discussion prompts. It is the sum of 4 consecutive numbers is an even number. Okay, again, the sum of 4 consecutive numbers is an even number. So you can see what I have started with is 2, 3, 4, and 5. Okay? So, one thing that I can do is I can take a look at this, and I know that I need to show that this always breaks down into pairs. Okay, so I can't just count these up and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Hey, 14 is even. I proved it. All that proves is that 2 plus 3 plus 4 plus 5 is an even number. It doesn't prove anything else. Okay. So I need to show that if I combine these together, I know that they'll always end up in pairs. So even numbers means that everything pairs up. Odd numbers means that you have an odd man out, somebody without a pair. So one fast way that I can think of doing this is I've got, let's see, I've got 3, and that's an odd number, and I've got 5, and that's an odd number. So if I take this guy and I move him over here, all of a sudden, all of my numbers are now even. Right? And if all of my numbers are now even, then I would be able to pull them down into pairs. So I'm going to put my sum over here, right? So I would take this, and then I'd have 2 pairs. Right? I know it's an even number, so I know it's going to come over in pairs. And then I would do the next number, and so on. And I don't really care what the sum is. I know it's 14, but I don't really care because I know that no matter what happens, I'm going to pull it down in sums. Right? I'm going to, let's see, do it a little bit different. Let's change the numbers. Let's do 3, and then 4, and then 5, and then 6. So I'm going to need some new guys. 1, 2, 3, 4, 5, 6. Gotta love the teddy bears. Okay, so this time I started with an odd number. So I've got 3, 4, 5, and 6. Right? It's the exact same situation now. I still have this odd number and this odd number. And if I give the odd man, right, from this number to this number, I now have all even numbers, and all even numbers are going to be pairs, and so when I put them all together, everything's in pairs. Right? Hopefully that makes some sense. I'm going to move that back. I'm going to show you another one. I'm going to line it up differently just because there's more room across. So let's do 3, 4, 5, and 6. Let's see, I have this. So 3, 4, 5, and 6. Right? So another way I could do this is I could, so again, repeating myself, another way to do this, and I like this way, I think it's pretty cool. If I look at moving these 4 to this row, right, and then I move these 3 to this row, I have 2 numbers that are equal. If I have 2 numbers that are equal, there is no doubt in my mind that that's going to be even, because Now I've got these pairs right on top of each other. Okay, so that's another way to do it. Another way, let's go back to, let's do 2, 3, 4, and 5. Right. Let's see if I can figure out how to erase. Oh, great. Just erasing it random. Let's see if I can get this to work out. So I've got 2, 3, 4, 5. I need to erase one more. All right, stick that there. There we go. All right, 2, 3, 4, 5. All right, so over here is going to be my sum circle. Okay, so I am going to work with the first two numbers. So there's a pair. There's a pair. And I'm going to ignore this guy because he doesn't have a natural pair sitting there. I'm going to ignore him for a second. And then I'm going to do the last two numbers together. And I got this guy left over. So these two come together to make that final pair. Now your job is to say, will that always happen? If you're not sure, start with some different numbers, 2, 4, 5, 6, and 7. You're going to find out because of the consecutive nature of the numbers, the first two, there's always going to be, when you add those together, there's going to be one straggler. The second two, there's always going to be one straggler that come together to make that last pair. Okay, I'm going to move on to a different proof. This time I'm going to do the sum of any 3 consecutive odd numbers is divisible by 3. So the sum of any 3 consecutive odd numbers is divisible by 3. So I think I'm going to do 3. So there's my 3. 5. And 7. I need another one. 2, 3, 4, 5, 6, 7. All right, sorry, teddy bear, you're not in a straight line. Okay, so I think the easiest way to show that something is divisible by 3 is to be able to make 3 equal groups, right? So 3 equal groups means you have divided, right, your objects into 3 equal groups, right? Divisible by 3. So what's the fastest way to do that? Well, if I take a look at this, I have 3, I've got 5, and I've got 7. So notice there are 2 more right here than the last one, 2 more here than the last one. Also notice that going from 1 to the third, the first to the third, I've got 4 more. So what's going to happen? If I take 2 from the last number and give it to the first number, all of a sudden I have split those teddy bears into 3 equal groups. Right? They've been divided up into 3 equal groups. So that means that my 3 plus 5 plus 7 is divisible by 3. Okay? If you're not sure on that one, again, start with different numbers. Do 5, 7, and 9. Figure out that if I take 2 teddy bears from the third number, from that 9, and I give them to the 5, right, I'm going to have 7, 7, 7 all the way through. Okay? All right, I'm going to get ready to do another one. Okay, so this next one is the sum of any 2 consecutive numbers is an odd number. Again, the sum of any 2 consecutive numbers is an odd number. So let's move these guys around so I've got some consecutive numbers. Let's try, looks like 4 and 5. So those are consecutive numbers. when you line it up that way, right, it becomes really, really obvious that this is an odd number when you combine these together, right? Because when you make your groups, when you're thinking about the sum, right, you're going to have bears match up in pairs. Ooh, bears and pairs. Except for the very last one, right? And he is going to be your odd man out. That makes it an odd number. So that is the easiest way to show the sum of any two consecutive numbers is an odd number. Again, convince yourself it doesn't matter what you start with. Start with 7 and 8, right? Or start with 8 and 9. Whatever you want to start with, you're always going to have all those pairs and then that one extra. Okay, one more. I am going to do the sum of 3 consecutive even numbers is always a multiple of 6. Okay? The sum of 3 consecutive even numbers is always a multiple of 6. And I'm going to set this up slightly differently. I'm using a different object because I want to have enough room here. And these are smaller than those teddy bears. All right, so I'm going to do 4, 6, and 8. Right, those are 3 consecutive even numbers. So when I do 4, I'm going to write it like this. So there's 4, here's 6, and here's 8. Alright, can anybody see why I did it this way already? If you've watched enough, if you're catching on, I hope you are, maybe you have an idea what I'm going to do. So I want to say it's a multiple of 6. Right? So that means I need even groups of 6. So I drew it this way because look what happens if I go right across here horizontally. I've got a group of 6. Right? I've got another group of 6. Wow, this is looking great so far. Yeah, I ran out in the first. And I've got extras down here. Well, guess what? All of a sudden, I have 3 even groups of 6. Right? So I'm always going to have those 2 extra here, right? That I can move over here, and it's going to even up the groups. Right? And then I'm always going to have groups of 6 all the way across. Let's do another one to convince you here. Let's do, I don't know, 6, 8, and 10. Oops. Move that guy over a little. Okay, so I've got 6, 8, 10. And those are consecutive even numbers. Look what happens again, right? I've got 2 more here and 2 more here. All I gotta do is move these 2 over, and all of a sudden, group of 6, group of 6, group of 6, and group of 6.